bottom here, you can see the different EBS data volumes and log volumes in place that the instances are using. So let's take a look. Let's say instance A goes away. Well, what happens? Replication will stop, and talking to the data volumes will stop. Now your monitoring would pick this up, and in a fairly automated fashion, what you can do is basically remap the elastic IP to the new instance. So your website.com now, transparent to the client, is going to a healthy instance. Instance B becomes the master and continues writing logs to the log volume. So that's a good example of how this can be done. Now, how would this look like across availability zones? Actually, very similar. You still see the replication here. Instead of writing to an EBS log volume, we're instead writing to Amazon SimpleDB now here in the middle. Reason is that EBS volumes are tied to AZs, and here we want to do something across AZs. So if there's something now in the availability zone that goes wrong, we have the left side here fall away. We have replication stop as well, and pretty much similar logic as in the first step here is remapping your elastic IP to the instance B, which is in another availability zone, and that instance now becoming the master and continuing to write to the log file. So these are examples that work really well within the region using multiple availability zones. All right. What's also important is to look at fault tolerance at each of these different tiers, right? So I think we had a good example of front-end systems and how they deal with it. So basically using multiple DNS targets, load balancing, auto-scaling, right, to make that work. At the application layer, it kind of depends on what the application is. Some of the systems have support for that built in. Others, you might have to do a little bit more. There might be session state considerations that you need to think through. At the data layer, that's often the most critical layer that needs to be replicated because that's where your state is. So each database system has various options of either synchronous or asynchronous replication, log shipping, mirroring things. Like the idea is to come up with with an architecture that doesn't have a single point of failure. And really across all layers, a best practice is to have good backups in place, to have a comprehensive set of tools and configuration data in place that easily enables you to put your system back into place. This is a nice little example that one of our customers, Netflix, came up with. They actually came up with the concept of a chaos monkey. So the chaos monkey is a little, it's not really a monkey, I guess. It could be a script that randomly goes into your EC2 account, for example, and picks an instance and shuts it down, right? So that's an example of what this monkey can do. And really the end result of what we want to see is that, nothing happens. The system picks up, hey, an instance failed, it puts a replacement in place, and the system continues just like it was. Now, a more complex monkey could go after specific instances and kill those, or you could really simulate the introduction or the existence of other faults, right, by shutting down networking facilities, by changing security groups, for example, and then just exercising how the system responds to some of these failures. Sometimes we also heard of human monkeys, where a dev manager, for example, and hey, goes in and puts a little pressure on the operations or dev team and says, hey, what if I start killing these instances? How does your system cope with that? And point here is you definitely want to exercise some of the failure modes and be resilient to even human error here. All right, in summary, we now have a architecture center in place on Amazon.com, so just aws.amazon.com/architecture. There are a couple of good white papers there about cloud architecture, best practices, storage options, security, and so on. So I certainly invite you to read more about it in this place. So with that, thank you very much.